WebAssign homework, I think it's in 4.3, when you've got systems of masses. And so I just wanted to demo a way to solve these problems, and you can apply this even when there's a pulley and things later. It first asks you to draw free body diagrams for each block. This question happened to be the question where you had a surface and you had two blocks that were connected by a string, and the block was being pulled with some force. And it was M1 and M2, and it gave you the coefficient of friction. So you want to draw your free body diagram separate for each body when you do problems like this. So you can see here I've got my free body diagram for M1, so weight of M1, the normal force, the kinetic friction force, and the tension. For M2, weight of M2, normal force of M2, the tension pulling back, the kinetic friction also opposing the motion from the force going forward. And then what I did is I set up my Newton's second law problems, each block individually, so one for each free body diagram. And so I have the sum of the forces in the x direction is MA, and that in this case is going to be the tension force and minus the friction force. And then I went in and solved, substituted in, and over here you see my work for how I got my normal force. I did the same thing over here for M2. An additional force, though, is you've got that pulling force here. That's directly on M2. And then you're asked to find both the acceleration and the tension force for the system. And so to do that, if you take these two equations here and add them together, you see that tension cancels out really nicely, which allows you to then go through and solve for the acceleration. Once you have the acceleration, you can then plug it back into either one of these equations here and solve for tension, and so you can see my work right there. So hope that helps clarify things for you a little bit, but when you've got a system of masses, they have the same acceleration, and so ultimately you will use both masses in calculating the acceleration at the end.